Welcome to this video on the steps of a hypothesis test. After watching this video, you will be able to state the purpose of a hypothesis test and then state the steps of a hypothesis test. Let's get started. What is the purpose of a hypothesis test? A hypothesis test is a process by which we determine whether the discrepancy between the population parameter and the sample statistic is an indication of a change in the population or whether it is merely due to sampling variability. In other words, in a hypothesis test, the sample statistic is different from the population parameter. The question is, are these two values different enough to cause us to reject the null hypothesis? Steps in a hypothesis test. First, we determine whether the requirements for the hypothesis test are satisfied. Then we state our null and alternative hypotheses. Thirdly, we use either the p-value or the critical value method to test the hypotheses. Fourth, we make a decision to either reject or fail to reject the null. Sometimes, instead of saying we fail to reject the null, we will say we retain the null. Lastly, we write a statement to summarize our findings. There are two types of hypothesis tests because there are two types of data. If we have categorical data, that means that we are working with labels. If we have quantitative data, that means we have counts or measures. For categorical data, we convert our labels into numbers by finding the proportion. So the population parameter that we use for categorical data is the population proportion P. This is the symbol that should be contained in our hypothesis our hypothesis statements if, in fact, we have categorical data. If we are working with counts or measures, then the population parameter is the population mean mu. Step 1, requirements for a hypothesis test. If you are working with categorical data, the sample must be a simple random sample. The product of n, p, q must be larger than or equal to 10, and the sample values must be independent of each other, meaning that the sample must be less than 5% of the total population. If you're working with quantitative data, again, the sample has to be a simple random sample. The requirements of the central limit theorem have to be met, and the sample values must be independent of each other. The next step is to state the null and alternative hypotheses. As you can see from this diagram, there are three types of tests. There are left-tailed tests, right-tailed tests, and two-tailed tests. Again, we have different hypothesis statements for categorical data, in which our hypothesis statements contain the population parameter P, which is the population proportion, and then we have hypothesis statements for quantitative data, where our population parameter is mu, the population mean. The third step is to use either the critical value method or the p-value method to make a decision. In the critical value method, you first use the significance level alpha to calculate the critical value. You will either use the inverse normal distribution or the inverse student t distribution. Once you have the critical value, you then proceed to calculate the test statistic, either using one of these equations, z-stat or t-stat, or using StatCrunch. Lastly, you compare the test statistic to the critical value. In the p-value method, you calculate the p-value. You can do this again either using hand calculations such as these and the inverse normal or the inverse student t distribution, or you can use StatCrunch to calculate the p-value. Once you calculate the p-value, you compare it to the significance level alpha given in the problem. Now it's time to make a decision. We must decide whether to reject the null or fail to reject the null. If we fail to reject the null, we could also call that retaining the null. In order to do this, we must compare the absolute value of our test statistic to the absolute value of our critical statistic. So if the absolute value of the test statistic is larger than the absolute value of our critical value, that means that the test statistic is falling inside of the shaded critical region, and therefore we must reject the null. If the absolute value of the test statistic is smaller than the absolute value of the critical value, that means that the test statistic is falling outside of the critical region, and therefore we retain or fail to reject the null hypothesis. If instead of using the critical value method, we use the p-value method, we can simply compare the p-value to our alpha or significance level given in the problem. If the p-value is less than alpha, we reject the null, and if the p-value is larger than alpha, we fail to reject or retain the null. The last step in hypothesis testing is to write a statement that summarizes our findings. The two possible decisions are to reject the null or to fail to reject or retain the null. If we decide to reject the null, the statement that we write is that there is sufficient evidence to suggest that, and then we just rewrite our alternative hypothesis here in words, not in mathematical symbols. If we decide to fail to reject or to retain the null, we just say that there is insufficient evidence to suggest that, and then we write in words our alternative hypothesis. Having watched this video, you should now be able to state the purpose of a hypothesis test and state the steps of a hypothesis test.